Hello, welcome to Wisdom Technology. So today, we're still gonna be talking about converting from binary to decimal, converting from binary to base 10, or from base 2 to base 10, whichever way you put it. So that's what we're gonna be talking about today. And if you have missed our previous course on Bitwise, please make sure you catch up your date. So this video is not going to take long. So I told you in the previous conversion of this video, I think the previous one before this one, I made mention of converting using what without using this sign, which is the percentage sign or the division sign, without using these two signs. So we're able to do that, and I explained in details what is happening. Actually, we are going to be doing the same thing too here. Um, but in this case, we are going to be making use of these two signs, which is the percentage sign and the slash sign. That's what we're going to be making use of. So this is not really bitwise related, but this is the normal way of converting from decimal, from binary to decimal, I mean. So let's get started. Next thing we're going to do is I'm going to make a C file. So I'm going to say VI mvim. So I'm going to vim into a new file. I'm going to call this file, let me say binary, sorry, binary, binary to, let me call it decimal, like that, dot C, binary to decimal. So I'm going to hit enter. So we have binary to decimal. So I'm empty this. I'm going to save that right away. Good. So we can start now. So let's get started. So the first thing we're going to be doing is we're going to check some stuff before we get started. We're going to be declaring a lot of stuff. But let's get started. Don't want to talk much, but if you know that you have not subscribed to this channel, please make sure you do that. So the first thing I'm going to be doing is you include the standard library. So I'm just going to put the include there, then the standard library. So inside it we have stdio.h like that, and we go over to the next one and we move forward. Now the next one we're going to be doing is we say int, then mean, like that. Then we're going to close this to call our method, or we call it the main function, whichever one is acceptable. So I'm going up and I'm going to pull this line. I don't want that line. Good. So if you want to learn how to use Vim very well, I have a full course on how you can use Vim efficiently, and we're going to drop that right away. So void, you can check my channel for Vim. The what's it called? The playlist of Vim. You see those videos on how to use Vim efficiently, and you get started. So we have void. Sorry. Your ID. Your ID. Good. Your ID like that. Then inside here we are good to go. Now the next thing we're going to be doing is we're going to be declaring some stuff. So the first thing we're going to start with is the decimal, like that. Then we're going to set it to 0, because this is going to be the total outcome of what we are doing. It's just like our total. So I can might decide not to call it decimal. Okay, let me call it decimal because I say from binary to decimal, so let me leave it as decimal. The next thing is binary. So I will have int, binary. So this binary is what we are receiving from the users. So based on the fact that we are receiving this from the users, we don't want the users to provide a negative integer. So I'll put that as unsigned integer binary, and I'm just going to close that. So you just take note that the first other course of this, we're talking about character, but in this we are talking about real numbers, so we can do mathematical operations and calculation on them, and it works just fine. So the next thing is, having done with that, we create the base. So I made mention of the base in the previous course, that this base increase in a multiple of 2 based on the explanation, but I'm just going to explain it here too, so you get the whole concept idea. So this is just set to 1, and I'll tell you why it is set to 1. It's set to 1 in case maybe I want to multiply 2 by 1. So I know that 1 times 2 is what? It's going to give me 2. Times 2 again is going to give me 4. But if I set it to 0, if I say 0 times 2, it's going to give me 0. Times 2 again, it's still going to give me 0. Times 3 again, it's still going to give me 0. Times 2 again, it's still going to give me 0. So I need to set it to 1. So me setting it to 1 will give a higher chance of what? Being able to multiply it with a good yeah. So let's get started. So that's this thing for there. Then the next thing is the remainder. So instead of me calling a remainder, I'll just call it last digit. So I'll say int. This will be holding the last digit. So this holding the last digit, because when we are multiplying, we start from the last digit to count 0, 1, 2, 3, and all that. So I just put last digit like that, last digit. So I can decide to leave it like that. Or you can decide to set it. No, you don't need to set it anything, just something changed. Then that's all we need here, and we are good to go. So the next thing we're going to be doing is I want to make it kind of listen, because in the last on the previous one I made mention of scanf. So we're going to be using scanf here to get some things done. So we don't want to leave this file. We want to work everything just on the terminal and keep going, going and going and going. So that's what I'm going to be doing. So the first thing I'm going to ask the user, so printf so it's going to be asking a question, simple question. I'll just put type in a binary, and we will convert it like that. So you hit that and we are good to go. Now when this line of code runs, the next thing that's going to run is the scanf. So scanf is used just like a form to receive data from users. So that's what scanf is. So I'm going to specify the format of data I want to receive. So the data I want to receive is a decimal, which is a number, not a float number. So I am going to put like percentage on a D, percentage D like that, then hit that. Then the next thing I'm going to do is I'm going to put the address of whatever the user is going to provide, which is this binary we have here. So I'm going to put the address over here. So I'll just put the ampersand, then binary. So this is going to set the value to this, what we have here, this thing. So that's what that's going to do for the moment, so it's going to receive it and store it in the address part of it. So that's setting it to the value. The next thing is we're going to go over writing our code. Now, why binary is not equals to 0, so one of the checking that with a while statement. So while binary is not equals to 0, binary is not equal to 0, like that. You see that? So that means the user provided something valuable, like 1, 0, not just 0. As far as it is not equal to 0, or there's nothing else to chop off out of that function, so we can go ahead and do something nice. So the first thing we're going to be doing is we want to get the last digit. So as far as it is a good number, like 1011, like this, we want to get the last digits. So the last digits, to get the last digit, you're going to use this last digit is equals to the value that is provided, which is binary, then percentage sign, then 10. I'll explain this so you understand what I'm doing. Now you can see that last digit is equals to binary percentage 10. Now what does percentage 10 do? Percentage 10 always return the last value of a digit. It's just like a model which gives us a remainder. So for instance, I have 22 divided by 10. So the remainder is going to be this. So it always gives us the remainder. So 22 divided by 10, that is what? 2. Remainder what? Remainder 2. So this remainder is what's going to give us. So this 2 is this last value here. Okay, let's try it with something else. So for instance, I have something like 100 divided by 10, something like this. So 100 divided by 10, that's going to give us what? It's going to give us what? 10. Remainder what? Remainder 0. Nothing is remaining. So this 0 is what? The last value here. Okay, let's try it again with something clever. So I'm going to pick 55 or 53, something weird, 53. So 10 goes into 53, that is how many times? 5 times. So it goes into 5 times, remainder how many? Remainder 3. That's what remainder. So you can see it's picking this last value. It's always targeting the last value. So that's what we are doing here. So the last digit is binary number. Whatever number that is provided divided by 10 is going to give us the last value. So if, for instance, we provide, because we're talking about binary, so for instance, we provide something like 1, 0, 1, 1, something like this, and you divide it by 10. So dividing by 10 is going to give us how many? This 1000, right? So 10 divided by 10 is going to go into it 100 times. 101 times remainder, because this or 10 remainder 1. So 101 times remainder 1. You can use calculator to bring out calculator. So what's going on? So we're gonna get rid of this, and 1011 divided by 10. You can see that it gives what? 101, which is the main value. 0.1. That 0.1 is the remainder. Remainder 1. So that's it. So I hope that answers. Now next thing, we have gotten the last value. What do we want to do with the last value? So I'm going to call the decimal. I tell you decimal is like the total value of everything. Decimal. So I can decide to say plus equals to like this. So I tell you this is the shortest method. Instead of using decimal is equals to decimal plus, all this is a waste of time. So use this, the shortest means. So plus equals to, so we're going to put the last digit. Like that, the last digit times base. So you can see that. So the last digit times the base. So we're gonna reduce that more. Last digit times the base. So the last digit here. So for instance, we have 1. The last digit here is, for instance, we have 101, and we divide it, and the remainder is what? The remainder is 1. So if you have gotten the last digit, which is 1, you now say 1 times the base. So now say have 1 times, what's the base? The base is going to be what? 1. You get that? So 1 times 1 is what? It's going to give us 1. You can see that. That's for the first step. So even if we have other values, it's still going to give us 1. But we don't want to do that. We want to be increasing the value of this too. So we want to increase. So I'm just going to hit enter. Then I'll say base. Because the base is always increasing based on, as I explained in the previous class. We have, sorry, I'm not adding it with 2 because that will be a wrong I there. I am multiplying it with 2. So that's what happens. So as I explained in the previous class, that we have binary, we have 1, 2, times 2 again, 4, times 2 again, 8, times 2 again, 16, times 2 again, 32, times 2 again, 64. Like that upwards and further beyond. Yeah, like that. So whenever this runs, it checks if the decimal is not equals to 0. That is, nothing is equal to 0. Now when binary is equal to 0, for instance, let me show you why this statement is important. I told you that we are dividing whatever we have here by what? 10. So we increase that, but we should note that when we multiply this by 2 and do it, yes, we have 1 times 1, and whenever it becomes 2 again, that is the next round when it becomes 2. So if it's now 2, like now base is no more what? The base here is no more 1 again. Now base has multiplied by 2 and base is now 2. So we will come back again. Here we now have pick the last digit. And when we are picking the last digit, if for instance we provide 1 over 1, on 1 over 1 we model it and it gives us what? It gives us what? 10 remainder 1, and we have manipulated the remainder. Now we should have it that whenever we go again, what is going to happen? You notice that the 101 will still be there, and we'll still what? Pass it through this 10 here, which is going to give us still 1, remainder 1. And it will keep on working on this value. The only thing that will be changing is the base, because the base will be increasing by what? Times 2. Times 2. So if we have 1, it will now be what? Still this the same last value. Then we're going to say times 2. So we'll say 1 times 2. We'll still pick again this last value again. We now say that what? 1 times 4. Like that. I'll be adding it up like that, like that. And this loop is going to run for everlasting. Will keep on increasing and it will run for everlasting, and it crashes your system. So we don't want to do that. So how can we remedy that situation? So for us to remedy that situation, we need to divide it by 10. We need to divide our binary by 10. So after this code run, and we have multiplied it by 2, the next thing we need to do is to we are going to divide it by 10. So we'll now say base, sorry, not base, binary, because the binary we are manipulating, binary plus equals to, sorry, binary divide equals to, just trying that to see if it works, divide equals to 10, like that. So it's still the same thing as saying binary is equals to binary divided by 10, like that. So they're still the same. So make sure you get that. Whenever you see me do that, that's what it means. So that is that. So the next thing is whenever this loop runs and everything ends up being 0. Now let me show you what ends up being 0. Now the first time we divide it by 10, when it runs again, you come back and divide it by 10. This is happen. So first time use this. I'm going to clear this and we use 101 and we divide it by what? 10. We have what? 10 remainder 1 again. We still divide it again, that 10 by 10. And what we have is 1 remainder 0.1. We still go ahead and divide it with what? 10. And what happens? It has become 0 point. So it's automatically 0. Now, we are putting in here that if the binary have divided, and as far it is not equals to 0, it should keep on running and keep on dividing. But if it has divided and it has reached the point whereby it is now 0, I want you to stop there and don't do any other thing. So we can go outside of this loop. When you go outside of this loop, you can then print the value of your decimal. Print F, then the value of the decimal. Come here and add some stuff there. And I'm going to be putting decimal, which is the total. Like that. And I'll come here and put percentage, because the decimal number, percentage D. Okay, let me make it look more interactive. This is your answer. Like that. And we are good to go. Okay, I'm not making use of that. Now that we have set that, I'm going to escape. WQ. Good. Now the next thing is I'm going to GCC, so binary to decimal. .c. I'm going to compile that, see if there's any error. Good, no error. So now we are going to do our a dot slash a dot out, like that. So now it's telling me type in a binary and we will convert it. So a binary number should be 1001. That, I think 1001 is 9. So when I hit enter, you see, this is your answer. You can see the answer, which is 9. and it's printed out on the screen, and it's affecting the terminal. So let me go and correct that right away. Oh, clear. So let me go and correct that right away. Good. So I need to put a new line over here, \n. Good. So I'm gonna gcc it again. I'm gonna e dot out. So type in a value. So I can just put 1000. That should be 8. And I hit enter. I say your answer. This is your answer, 8. You can see that. I can run that again and type in 11, which is, I don't know why it's 3 or 3. It hits it. Say your answer is 3. Type something like 00011. Hit enter. Oh, sorry. What am I doing? I'm running that again. 000. Sorry. Type in a binary, so I put 00011 and I hit enter. See, your answer is 3. So I can still go and run it again. I put 1010, hit it, we have 10. I can put 0 1 like that. What? Just type. I type 0 1, so expecting me something else. So I've typed 0 1. I forget to execute that. The answer is 1. So let me see if this code has any issue. So let me type something like 344. Oh, you see that? This is your answer, 24. You can see, if I type something like 20, the answer is 4. You can see? So this is not really good enough. I mean, not really good enough. Not good enough for that. But the first one is more preferable, but this has a loop side. It works with a little issue. Has a little issue with this. So you make sure you stick. Let me see if there's anything else. Okay. Let me put a return statement there. Return statement like that. So let me just see that. Okay. E dot out 1 2 3 and size 11. So I don't know what calculation is going on there, but you can go ahead, look through your codes and figure out what is going on based on the explanation, because no more time. But actually for the main binary conversion, it works, but it has issue, which is a very big issue that you can treat later on. So thank you for watching and have a nice day. So please, if you know that you enjoy this and you really understand my teaching, please, I want you to subscribe to my channel, and God bless you. Have a nice day.